Ich ni san shi go loco. Last one. Oh, yes. And it's one of these convergence problems, right, that we've been working so hard. I'm sure they're going to throw a curveball on us. So let's go ahead and take a look at it. Let me, I'm going to screenshot this guy right here just so I don't have to keep on writing it, because I bet you we're going to have to use that dude over and over and over again. Darn it. Didn't erase this, but here we go. All right. I'm going to start reading it here over to the side. It says, state the conditions necessary. Yep, and this is when you guys said, darn it, they threw an integral test guy on us and an LCT on us here. All right, so my best guess is, hey, you worked on that path to a 5, and you were probably okay. All right, and if you really did it and really worked on that guy, I'll bet you were okay. All right, so we're going to use the integral test, and they asked me to discuss the conditions necessary. Remember, this is the DCP. So I needed to state that f of x, which is equal to e to the negative x, right, is both positive, continuous, and a decreasing function. And if we do that, it enables me to use the integral test. Now, what exactly is the integral test? Well, remember, the integral test is we're just going to take the integral, we're going to change the n's, okay, and remember, the problem started out here as the series of n equals 0 to infinity of 1 over e to the n. So the integral test means, hey, we're just going to turn this into x's and we're going to do work. That's it. And you have to remember, this is an improper integral, so the AP wanted to test us that we were going to change this into a limit. Remember, you have to do these for response questions. But you know what? This isn't too bad. Hopefully, if you forgot this, hey, you still just did the integral test, right? Which is just an integral, all right? Which thus turns it into an improper integral, like I stated earlier. That antiderivative is simply this, whoops, negative from 0 to b, which is equal to the limit as b approaches infinity, right? This isn't too bad, you guys, which is that b plus e to the 0. Now, when we substitute in that infinity symbol, right, that's going to turn into 0. Right? So if I wanted to, I could rewrite it like this. Do you necessarily have to do that? I doubt it. Okay? And that's just going to be equal to 0 plus 1, which is equal to 1. So remember, since this, I'm not going to write out the statement, but hopefully you did. Since the integral converges, and it's a decreasing continuous positive function, I can say that this series converges as well. Remember, that's all, you guys, that the integral test is. All right, let's go ahead and look at the next piece. Okay, so the next piece, ooh, this one's a little bit, okay, I'm looking at it here real quickly. It says use a limit comparison test, but you know what's kind of nice about this one, you guys? They tell me what to use. Okay, they tell me what to use, and this converges absolutely just means we're going to do the absolute value of it. Okay, so we're going to throw it without the alternator is what we're going to do. Okay, so we've got this, the limit is, okay, and we're going to take, and remember, when we do our limit comparison test, we just do the one over the other, right? And you guys remember, it does not matter which one is in the numerator and which one is in the denominator. Remember, when we do this guy here, I get e to the n. We're going to absolutely, which means absolute value. Okay, we're going to do it without having that alternator in there. And hey, this is really just an n behavior model. Now, the question is if I plug in an infinity, I really get infinity over infinity. So here you're in question is, did they want me to use LHOP? You know, did I have to LHOP it? Which I guess you could have. We'll have to see when the grading comes out how specific they were. In the past, if they wanted LHOP, they would maybe tell you, right? That's infinity. But then when you do the derivative of the top, you get e to the n. When you take the derivative, you get that spling, they cross out, and then you show that it's equal to 1/2. Now, remember, when we do this limit comparison test, if you get an answer that is both finite and positive, then hey, easy peasy Japanesey, right? Since this equaled converged, or I mean equaled something finite and positive, then I know, or scratch. Man, I'm almost getting my test messed up, right? You guys at home, you about said it, right? Since this dude, right, what I'm comparing it to, and I'm comparing it to this, and since this guy right here that converges, right? And that just converges by a geometric series test, right, you guys? So since this guy converges as well. Okay, and that's all it is. All right, or this dude by itself converges. Okay, whew, I kind of butchered that one up. Doing these fresh, clean can be a little bit tough sometimes. All right, but hopefully you did that. Remember, any comparison test, we compare it to what we are comparing it to, and since 1 over e to the n converges, and we showed that the limit comparison test was both finite and positive, then we know that the original, which was the alternator uh, over 2, or the original, that converges as well. And that is obviously when x was equal to 1. All right. So here we go. Let's go ahead and go to part C. Oh, part C is just a radius of convergence. So hopefully this wasn't, and that's all you had to do for this one. Okay, so this probably wasn't too bad at all for you guys. Okay, it's just a ratio test guy, which would be -1. Oh, we can just throw out that, right? We can just throw out the alternator. So it's x to the n plus 1 over 2e to the n plus 1 plus 3 multiplied by the reciprocal. Oop, don't need the alternator. So we get that. That simplifies to the limit as n approaches infinity. Let's see, we end up with an x upstairs. Now here's the same thing as what we did before, right? This would be e to the n times e. Those guys would cancel out. So the 2's would cancel out. Once again, you could L-hop it. Now I would say for sure in this situation, you would not have to do it, okay? And we get this guy right here. And remember, with the ratio test, we want to know if it's less than 1. We take the limit. There's really no n's to deal with here. So you just end up with the absolute value of x over e. There, oh, come on. You guys dominated that bad boy, right? And then we just have one piece to go. Can I fill it in with the work that is left? Let's see. They say find the first 2 terms. Ooh, I better erase this. Looks like it's kind of involved. It says find the first 2 terms to approximate g of 1. Use the alternating. Oh, sweet. And it's the first 2 terms, so we're going to go to the third term, right? Okay, so this is g of 1, which would make that a 1. And we just want the first 2 terms, okay? So g of 1 will be approximately equal to the first term would be plugging in a 0. If I plug in a 0, I get 1/3, right? Boom, boom. No, I don't. Plus, I get 1/5, right? Because a 0 would be positive, 0 there would be 2 plus 3. And then plus the next term, we would plug in a 1, so it's going to be negative. It'd be 1 over 2e plus 3. Okay, so that is used to approximate. And then what do we want to do? We want to find the error. So the error would be the actual answer for g of 1 minus these first 2 guys, right? Whoops, plus negative. Okay, and that is going to be less than the absolute value of the next term. And the next term would be plugging a 2 in there, which would be positive. Plug a 2 in there, 2e squared plus 3. That's it. That's all you would have to do. Oh my gosh, was that really all it was there? That's all it was. And that is a wraps on the 2021 BC exam, which I will guarantee you guys dominated. Aloha! Excited to see those scores in July.